Welcome to the debate. Uh, Imagine this. Your business relies on an AI to answer customer support emails, right? And out of nowhere, it just hallucinates a generous refund policy.
Oh, that is a nightmare scenario.
It literally costs you thousands of dollars, all because it autonomously, decided to be helpful. That is the exact tension we are exploring today. We are looking at the fundamental architecture of modern business automation.
Right. And I think it's 75% of small businesses now adopting AI tools. The way we structure these systems is just a critical operational imperative at this point.
Absolutely.
So we are diving into a comprehensive source analysis of N8N, automation, API integrations, and system design. And the central question is really this: should businesses default to highly controlled, deterministic AI workflows? Or should they embrace the autonomous, non-deterministic decision-making of AI agents?
Well, I am firmly in the camp of linear AI workflows. Strict guardrails and node-by-node reliability are absolutely paramount.
I figured you'd say that.
I mean, if a business process is sequential, relying on an AI's autonomous reasoning is just a massive, unnecessary risk.
And I take the completely opposing view. Modern business environments are not sequential. They are messy, they are unpredictable,
Okay, but
and that reality requires the dynamic reasoning and adaptive capabilities of autonomous AI agents.
let's ground this in how these systems actually operate, though, because most business processes are, in fact, linear. Look at the CRM example from the material.
Sure.
You get a new HubSpot lead. You send it to Perplexity for research. You route that data to a large language model to draft a personalized email, and then you just push it out through Gmail.
The classic pipeline.
Exactly. In a workflow, that is a deterministic, hardwired pipeline. Think of it like a physical set of train tracks.
Okay.
The data can only travel where the rails have been laid. It guarantees predictable execution every single time, simply because it physically cannot deviate from that path.
Right, but it executes perfectly only if the real world behaves perfectly.
What do you mean by that?
Well, I remember building a workflow for a client last year that crashed their entire sales pipeline. Why? Just because a user typed out the word 20 instead of using the number 20.
Ouch. Yeah, that happens. Well,
Right? That is the fundamental brittleness of workflows. Agents, on the other hand, are built to handle that exact unpredictability.
but at what cost?
Well, instead of running on a fixed track, an agent operates under a system prompt, which is basically its job description, and it uses short and long-term memory to retain context. It looks at the user input, assesses the tools it has available, and dynamically decides the best path forward.
I see why you think that, but let me give you a different perspective. Walk me through the actual economics of that.
Okay, sure.
If we know exactly what the 4 steps of a marketing task are, why should a business pay for an AI to repeatedly think about what to do next?
To prevent those crashes we just talked about?
But if you are listening to this and wondering why your API bills are suddenly skyrocketing, this is exactly why. Every single time an agent considers a tool, it has to hit the API, run its entire system prompt, and burn through OpenAI tokens.
I mean, technically, yes.
So why pay for a machine to continuously deliberate when we can simply hardwire the logic once?
I'm sorry, but I just don't buy that. Let me tell you why. That token cost is an incredibly cheap insurance policy against operational failure. We're talking fractions of a cent per token here.
It adds up at scale, though.
Sure, but look at the Perplexity web search integration from the source. In an agentic setup, the agent dynamically uses a from AI function to generate its own JSON search term based on the nuanced intent of the user.
Right, reading between the lines.
Exactly. If a user asks a highly ambiguous question, a workflow just fails because the query isn't perfectly formatted. But an agent recognizes the ambiguity, it formulates a precise search query, sends that specific JSON parameter to the API, and then reads the results to decide if it needs to search again. That contextual pivot is invaluable.
I'm not convinced by that line of reasoning because, well, look at what happens when that insurance policy fails. And they do fail. Debugging an agent is an operational nightmare.
Is it, though?
Yes, because all that dynamic reasoning happens inside the black box of the LLM. If an agent hallucinates a parameter or sends the wrong data to a tool, finding exactly where the logic broke down is incredibly difficult.
I mean, you can check the logs.
But compare that to workflows. In a node-by-node setup, your visibility is absolute. If I get a 400 bad requests error from an HTTP request node, I can look at the exact JSON string being passed between those nodes.
Right, you see the payload.
If I spot a misplaced double quote that invalidated the JSON, I just fix the quote and boom, the system runs. It's right there in front of me.
Yes, you can see the error, but the error just crashed your entire system. An agent actually has a capacity to self-correct.
Self-correct?
Yeah. Think of an agent like a short order cook reading a complex, customized ticket. They don't just blindly follow a rigid recipe. They check what ingredients they have, look at their appliances, and adjust on the fly.
Okay, fun analogy, but how does that apply to the JSON?
Well, if an agent sends an invalid JSON request and gets that 400 error back, it can read the error message, it realizes it put a double quote in the wrong spot, fixes its own formatting, and resends the request, all without you ever having to wake up and fix the code.
I get how impressive that sounds, but allowing a system to figure out what wasn't explicitly programmed is exactly how these architectures scale completely out of control.
How so?
Because true scalability relies on modularity. With workflows, adding functionality is as simple as snapping in a node. Need to pull local business data?
Sure, you just add the node.
Right. You snap in an Apify HTTP request node to scrape Google Maps, map the output to your spreadsheet, and you're done. The core logic remains pristine.
But
wait, when you add more tools to an agent, you have to expand its system prompt. Give an LLM 20 tools instead of 3, and the model starts getting confused about which one to use. The reliability of its previous simpler functions inevitably degrades.
that is a compelling argument. But have you considered that true scalability is conceptual, not just additive?
Conceptual scalability. What does that even mean?
It means pinning 100 bespoke nodes to a canvas doesn't make a system scalable. It just builds a labyrinth you have to manually maintain.
I wouldn't call it a labyrinth.
An agent equipped with OpenRouter for model selection, Tavali for real-time internet search, and a memory module can handle infinite variations of a task, like generating dynamic LinkedIn posts and DALL-E image prompts based on real-time research. To get that same coverage with workflows, you'd have to manually build hundreds of rigid, bespoke paths.
Okay, but
And just explain how that works in practice. A vector database like Pinecone takes all your company's data and plots it on a massive multi-dimensional map based on semantic meaning.
Right, so it's mapping concepts, not just exact keywords.
Exactly. So if a customer asks, a highly specific question about a warranty policy, the agent explores that map, it locates data points that share the same context, even if the exact keywords don't match. It retrieves that data and synthesizes a perfect response to a scenario you never explicitly programmed it for.
It is a fascinating mechanism, I will give you that. But I maintain that leaving the steering wheel to an unpredictable semantic engine introduces unnecessary operational risk.
Yeah, we definitely disagree there.
Deterministic guardrails and absolute node-by-node visibility are what keep a business running reliably day after day.
And I still argue that you cannot hard-code your way out of every variable. The messy, non-deterministic nature of the real world really just demands the autonomous reasoning of AI agents.
Well, despite our structural disagreements, there is a profound point of convergence in this material. Whether you are snapping together a strict workflow or letting an agent route itself, the technical foundation is exactly the same.
Totally. You have to master API connections.
Yes. Understanding how to hit specific API endpoints, how to properly format JSON payloads, and how to pass authorization keys.
Like bare token headers, yeah. That is the unavoidable prerequisite to succeeding in this space, no matter which architecture you choose.
The tension between strict control and dynamic autonomy is exactly what drives the innovation we are seeing. It forces architects to ask what needs to be rigid and what needs to be flexible.
Exactly. It forces us to build systems that reflect the reality of the problems we are trying to solve, and there is so much more to explore in the source material regarding these specific node integrations too.
So, do you rely on a system where every single data transfer is hardwired, visible, and strictly confined to its tracks? Or do you hand the keys over to an autonomous engine that reads, reacts, and rewrites its own requests on the fly?
It's a tough call.
That is the choice architects must make. Thank you for joining us on The Debate.